So my name's Anthony Spiteri. For those that don't know, I'm also a global technologist in the product strategy team. So I'm going to go through our clouds here in this particular section. So this is actually a really interesting product. It's something that we released as part of Update 4, which was released in January at Velocity event, our partner conference. And it's something that we're very proud of. We think, and I personally, this is one of our most innovative features that we've released in a very, very long time. So what I'm going to do, I'm going to take you through a little bit of an overview, and then I'm going to go through a deep dive into some of the technology and how we're doing things differently to other vendors out there. And then also I'm going to show you a bit of a demo about some of the cool applications of the technology as well. What I'll say, just in terms of time, because we're running a little late, is I've got some, I guess, dead time during the demos where I think we can get a few questions through, okay? So I'll try and power through this, get to the demos. Obviously, if you guys have got a pressing question, feel free to up. But yeah, let's rock through this. Before I start, it's important to sort of talk about a glossary when we're talking about the clouds here, because effectively what we've got here is we've got a number of different terminologies that you're going to hear over the next 10 or 20 minutes. The cloud tier itself is a marketing name that we basically gave to the feature. We're very good at obviously doing umbrella names throughout some of our features. So if you hear clouds here, it's basically the umbrella tag of this feature, meaning that in the future when we add functionality to it, it's still under that cloud tier marketing name. We have object storage repository, which is basically a repository that is backed by Amazon S3, S3 compatible, Azure or IBM Cloud. We've got the capacity tier. Capacity tier is a name given to an extent on the server that is using the object storage repository. And then we've got the scale-out backup repository, which Michael's talked about briefly, which this is all based upon and part of as a feature. Okay, clear as mud. It'll be a little bit clearer later on. In terms of the clouds here, the overall premise of the actual technology was to basically get some native object storage integration. Okay, extend the scale-out backup repository to use capacity tier, which is backed by that object storage. In effect, what we're doing here is we're extending the scale-out backup repository to have unlimited capacity, okay? Leveraging the power of S3, Azure Blob, to basically make your scale-out backup repository almost infinite, okay, in size. We don't double charge for this functionality. Now, it's very important to understand that basically when you get Veeam, you pay for the license, you get backup and replication, and depending on the license type, you'll get this functionality, okay? Which means we don't charge per gig for data that you store in a public cloud or in fact anywhere, if it's even a local repository, okay? Very important that. And no lock-in, we've talked about our agnosticity, okay? The fact that you don't need specific hardware to target, to run our software. It's the same approach here. We give our customers the flexibility and the freedom to choose the object storage of their choice. Okay, very important. In terms of what we're talking about here, fundamentally the clouds here is about shifting data from what is more expensive storage locally to what's cheaper storage off-site. Okay, it's fundamentally what we're trying to do here. And this isn't an archive solution. This is a tiering system here. So it's very important to understand exactly what we're doing here. We're not sending a big chunk of the data up. We're basically tiering little chunks and basically have one copy of the data. They could be in the local operational restore window, or they could be in the object storage, okay? It's a very, very important capability of this system because what we've done is we've effectively turned Sober into a file system as such for your backup repositories. The best analogy that I can use is if we think about the old VNXs, people still use them, so they're not quite old, but you know, they had the fast tiering, right? Where they had the algorithm that ran every night and shifted that hot data into SSD. That's effectively what we're doing here by way of an analogy. Only the difference is we're shifting blocks of data from your local, what we call performance tier, which is that landing zone, up into the object storage. Okay, and we'll get into the nitty-gritty of how it's actually doing that a little bit later on. The Veeam difference, I've talked about this. I'd like to just reiterate it. We don't charge that subscription fee. It's very important. Okay, again, simplicity for our customers. How we do it is we basically have this offloaded backup file. So we dehydrate the data from that local repository to the cloud repository, okay, or the object storage repository. What we leave is what we call a dehydrated shell, and that shell contains metadata. There's a graphic on the next slide which will show that process at a top level. Shells are still local, so it's really interesting, and we'll see this in the demo, is that when we dehydrate the data, for those that know Veeam, the VBK file itself is still present locally on that performance tier. But all the data is sitting in the object storage, okay? But the actual physical file is still there. And that's important for a number of reasons, because it lets us basically still let us rebuild objects if we lose data. And what we're also doing is we're doing per job dedupe as well. So we're effectively doing source-side dedupe by shifting only blocks that we require up to the object storage. We don't shift the same block twice. So on that, we've kind of got that source-side dedupe going on. But this is probably the biggest thing, is that you don't lose functionality, okay? So when we actually move the data into the object storage, because that VBK file is still present and still accessible via the UI for the console, we still treat it as such. So we can right-click and do all the actionable items that you know and love with Veeam. Instant Veeam recovery, per file backup, restore to Azure, restore to EC2. Basically, all that functionality is still there. And that's a key. And it's because of the way that we're actually doing this. Because we're tiering the data with pointers locally from the performance tier to the object storage, we can do all these actions, okay? Now, the difference here as well is that if you're shifting big chunks of data up to the object storage, you've got to pull it all back to do functionality, okay? That's an archival solution. Again, tiering, I've reiterated that a few times. It's very important to understand this as tiering. And the last thing is that we also do, not only do we do, I guess, intelligent uploading of the blocks, but we've got what we call intelligent block recovery, okay? Which means that we are going to be looking locally for blocks of data for restore or rehydration operations, which obviously means from a public cloud perspective, you're going to be saving on the egress charges where you guys get hit mostly if you're using S3 or Azure Blob, but also it acts to speed up the restoration process. So we've built in a lot of smarts into this technology to make it more efficient for our customers. And this is a nice simplistic overview of how we actually do it. So if you have a look here on the left-hand side, we've got a VBK file. Michael showed you the construct of that a little bit early on, so this is a more simplistic view of it. We've got the metadata in, and then we've got the data chunks. So what we're going to do as part of this process to move it is firstly we'll move the metadata into the object storage and the capacity tier. And then we'll shift those chunks of data across, and what we're left with is that shell or that dehydrated VBK with just the metadata sitting locally, okay? In terms of supported capacity tier extents, I've talked about S3, more importantly from the point of view of choice, S3 compatible storage. So if you guys are running a Ceph system, cluster FS, the EC2 electric block storage, that's all compatible, okay? What's important though is that it needs to be of an AWS signature v4. Okay, for those that know AWS, there's a couple of different signature types, v2, v4. For this to work for S3 compatible, those repositories need to be of type v4. Now that effectively is akin to an SSL certificate, where these days you wouldn't typically use a 1024-bit key for SSL, 2048 at the least at the moment. That's basically the difference between a v2 and a v4, okay? And AWS is pushing very heavily the use of v4 across everything that they do now. Amazon S3 is obviously supported with S3 infrequent access. You'll notice that Glacier isn't on that list. Not quite yet. Again, more because of the time to first byte with Glacier. Understand this is a tiering system again. These blocks of data need to be readily available to basically do all those operations on, which is why at the moment it goes into S3 and S3 infrequent access. And Azure Blob Storage at the same time. So at the moment, as of this version, this is the compatible object storage repository for the capacity tier.
Just a question on that. So do you plan to support Glacier? If I accept the speed to restore, I sign off on that slower restore, will I be able to do Glacier possibly in the future? And also, will I be able to use Glacier Deep Archive?
Yeah. So to answer the first part of the question, it's something that we're looking at. And in fact, the first iteration of this product, when we announced it a few years ago, before we G8, it had Glacier as a supported. But then when we decided to go more to that tiering system, for the reasons I've said, we didn't choose Glacier, but we are looking at how we can make it implemented in future versions. And the second part of that would be yes, to be able to take it and basically, I guess, tier it off to a deeper storage. So the idea behind this is to create a full tiered system, right? Where you go from spinning disk to SSD to cloud to deep storage cloud to even more long-term cloud. That's the idea behind it moving through the future. Yeah.
Are all tiers of Microsoft Azure's blob storage supported? So has it got hot, cool? I think they've got like deep freeze kind of one.
Yeah, the deep freeze, the archive is not, but the top two.
Top two are, okay. And there's now a performance tier as well. Is that supported or is that might still be in preview?
I believe that does work, but not officially supported.
Okay.
Okay, yeah.
Okay.
So what will happen there is when we obviously release periodic updates, and through those updates, the supportability will always increase. That's always what we do. So you'll find as we release supplemental updates, we'll be supporting more and more platforms.
Okay.
Oh, sorry.
So even in that 4-tier model that you're describing, where Deep Archive is part of the scale-out backup repository, is there not still a dependency on on-premises data? What happens if that's lost? Can we still leverage our archive?
Of course, yes. So I'll get into that a little bit in the deep thing, but basically what we're doing is we're very resilient in this file system. So effectively what we've done, we keep an index. That index is copied to the extents of the scale-up backup repository, each one if you've got multiples. So we know where the data is. Now obviously the local data, that's there. If you lose that, then basically you've got no recourse to pull that. But you can always call back on the data that's in the object storage to recover from if it's outside of that operational restore window. And in fact, that's going to be my demo later on, so you've kind of read my mind there. Okay, deeper dive. So the question is, how does data get offloaded? Basically, two conditions need to be met for the data to be offloaded. Okay, we've talked about this operational restore window. Basically, when you set the policy on the scale-up backup repository, you've got the option to set an operational restore window. That's effectively your landing zone. So what you were talking about that local data in the performance tier, that's it. So you've got the flexibility to set that landing zone to anything you want, 30 days, 90 days, 14 days. You can set it to 1 day, you can set it to 0 days if you want as well. Okay, so you've got the flexibility to decide how much data you keep locally. Like Michael talked about though, we always say that it's better to have some sort of data local for faster restore, instant recovery, all that kind of stuff, and obviously then push out the rest. And you'll see exactly where it comes into play in terms of advantages of what types of backups are great for the actual object storage itself. And then we've got a sealed backup chain. Now this one is interesting. For those that know Veeam, a sealed backup chain effectively is a chain that is no longer under transformation, okay? And I'll explain that a little bit in the next couple of slides. The offload process is interesting. So backup data is collected from our extents. We then work out what data is a candidate to be moved based on those conditions that I've talked about earlier. We then basically use an offload job via the Veeam agent at Exe, which effectively shifts that data and does all the work that you've seen before. The object process is done via that job, and it runs every 4 hours by default. Okay? So as soon as you configure the job, as soon as you enable it, it'll run 4 hours from the time you configure it. Now there is 2 ways to automate that, or to manually, I guess, force that. You can do it via PowerShell, and there's a way through the UI as well to right-click. We've hidden it, because we feel in the design that every 4 hours is a good period of time to send data up. Okay? Understanding when you're taking your backups, depending on the amount of snaps that you're taking, the frequency of your backup, whether it be 4 hours, 8 hours, 12 hours. I mean, typically people do every 24 hours, but they can obviously shorten that. So we felt that 4 hours was a good medium to basically have that in play. Yes, Chris?
Does Veeam offer a method to throttle the job, the transfer speed for that job?
Yeah, so we've basically got a section in our network connectivity which will let you throttle that and control the data out. Yep. Yes?
I have a question. Can it work for containers?
Or what, sorry?
Containers.
For continuous backups? No. So I'll get into that in a second here. So let me go through this slide because it'll explain that. So effectively in terms of a sealed backup chain like I've talked about, so if you've got forward and incrementals, okay, we've got a couple. Michael talked about forward, reverse incrementals. When you've got a forward incremental, it's not sealed until we create an active full or a synthetic full, okay? Once we do that on that Monday, that chain previously is then sealed, no longer under transformation. That's when that can go up, okay? That's when it's a candidate to go up. Now, if you guys have forever forwards, which a lot of people do have today, it'll never get sealed. Forever forward backups or continuous never get sealed. Therefore, even if the data meets the age requirement, it'll never be a candidate, okay? The sealed backup chain is very important in this sense. When we look at the reverse incrementals, basically that component will be a candidate to be uploaded. And interestingly enough, when we're doing reverse incrementals, the first two reverse incremental files are always under transformation, okay? And that's why they don't actually appear there as a candidate to be moved up. When we're talking about backup copy jobs, BCPs, GFSs, basically, and this is a very popular type of backup. And as I was talking about earlier, in terms of the type of backups that are perfect to basically offload data from that local repository to the object storage, the GFS backups are huge, including for our cloud providers. So hopefully later on we'll talk about the Veeam cloud and service providers who offer Cloud Connect backup. The majority of those that are going to those guys are all backup copy jobs, GFS backups, usually the biggest ones and the oldest. So straight away, if you have Veeam and you install Update 4 and you've got a big local repository, you enable the capacity tier. After a bit of time, once you've set those policies, it's going to look at these GFSs and go, I see that those particular VBKs, which are all self-contained, they're all sealed. We're going to shift those up to the object storage, and you're going to free up a ton of space locally. So this actually fundamentally changes the way. Yep, go ahead.
Is there a report you can run to determine what is suitable or what will be moved, so you can get an idea of how much space you're going to save locally and how much is going to be shifted up?
Not officially. There's some PowerShell commandlets that are being developed to basically get that done. We're working on better reporting and metering and future calculations to be within the system in the next couple of versions.
Right,
So yeah, at the moment, obviously released it up here. It's a question that we get often in the product strategy team working on this product. How do you size it? How do you deal with? How do you know it's going to be shifted up? The best thing to do, really, in this case, is to look at all your GFSs and kind of tally them and go, well, look, I'm going to save X amount. We obviously want to do that in an automated way.
Right. What does GFS stand for?
So GFS
for
is
those that aren't familiar.
Grandfather
like me.
son. So grandfather son.
Okay.
Old school sort of
grandfather
terminology for backups,
Right,
typically
okay.
with tapes. That's effectively what we're doing there.
All right, so it's not a Veeam specific.
No, that's
You're talking about
that's
the
a typical backup,
general GFS. Okay.
backup term, yeah. Okay, and I guess what I was talking about before is that thinking about what this does to the design of a backup repository system. Okay, all of a sudden, where your focus was local in the performance tier, worrying about scaling that out, growing. Data's growing exponentially, right? We all know that. So I've operated backup systems and backup platforms. I'm sure many of you have. The biggest headache is when that data grows and you run out of storage, and you've got to go, oh, shit, I've got to get another array. But is that array going to fit in my rack? I need more power. There's a whole heap of things that come into play with that. With this, you can fundamentally change your theory and the way that you architect that local repository, because the majority of your data is going to sit externally on that object storage repository, whether it be public cloud, your own S3, whatever it is. Okay, so it's actually really significant. And again, goes back to our hardware agnosticity, the fact we're software driven. Okay, the flexibility in this particular technology is amazing, which is why I think it's great. Okay. In terms of what it looks like at a very easy level, this is an example of a few blocks that sit within backup files. We've got the operational restore window, we've got the performance tier, we've got the capacity tier. So what we basically do is we look at those blocks that sit outside an operational restore window. We then shift the blocks across into the capacity tier and basically dehydrate those files on premises. Okay, pretty simple representation of it. It's a good visual. We're getting into it a little bit deeper here, okay? In terms of dehydration process, so what's happening is for every single file that's living on premises, when we shift it to the object storage, we create a pointer file, a metadata file as such for that particular file. That particular file itself then has pointers to the blocks of data that we're shifting. Remember the graphic before where we shifted data into the object storage? Basically, for VBK would be file 1. Vib would be file 2. Now when we shift VBK up, we've obviously got blocks A, B, and C. They're shifting into the capacity tier. So file 1, which is the pointer file, knows where A, B, and C are on the object storage. When it comes time for Vib, it'll create the new pointer. Now because Vib has got A, B, and D, there's similar blocks. Remember I talked about source-side DGIP? This is where it basically comes into play. So what we'll do, that secondary file will be created, but it'll point to the blocks that have already basically been uploaded. Okay, that's some of the great technology we've built into this. Okay, very innovative. and more like a file system, really, when you think about it. But this is basically how we've done the reduction. And what this means is that the data that we're sending up is never going to be as big as what it was in the performance tier, because we're getting to the efficiencies with this source-side block replication.
I have a question about
Yes.
the dedupe process. These dedupe scope, is that specific to a backup set? Is it a global dedupe? What's this?
Yeah, so no global dedupe. Basically, when we're this is like effective source-side dedupe. When we went to design this, if you guys know about ReFS file system and the way that it does its block cloning and its reduction data, it's similar to that. We look at the blocks, we go, which one's up there? And then we go, well, let's upload that. That's dedupe. So when I say specific deduplication, it's not as you would expect it normally. It's more like deduplication in terms of us sending the data up.
Right, so you don't send up a block you've already sent up
That's exactly
for
it.
that particular backup.
Yeah, that's correct.
Okay, and that index, the dehydration index,
Yep.
can that be replicated somewhere else so you
So
don't lose that index?
That is natively replicated. So that's replicated on the performance tier, on every single extent that you have. It's also replicated into the cloud as well, into the object storage.
Right.
So we've been very, very particular about the resiliency of this. Yep.
Okay.
Okay. In terms of rehydration, so I talked about that intelligent block recovery. When we're pulling the data back, now we're taking it from the capacity tier to the performance tier. We're looking to basically restore full backup 1. I talked about the fact that we've got the intelligent block recovery. What we'll do is we'll look at the oldest local backup first and work out if we've got the blocks locally. If we do, we'll pull them first from the local and we'll pull it into the file. So we'll rehydrate that way. And only if we don't have a block locally will we go to the object storage and basically pull it and rehydrate from that perspective. Okay? So again, intelligent block recovery, saving on egress, saving on time to actually recover the data. When we're doing a recovery, same sort of thing. We'll look locally, and then we'll look at the capacity tier itself. Okay? Estimated sizing. This is, where it becomes interesting in terms of how we size this. Veeam by default has 4 different levels of block sizes, and this is basically what you set when you create a job in Veeam. The default is set to 1024, and this is all before compression, by the way. So in terms of the block sizes that we're sending up into the object storage, it's based on this. This is how we'll chunk it up, basically. So if you've set your backup job for WAN, it's going to be 256. That's before compression. So when we compress it, it's obviously going to be half that. We get about 50 to 60% compression in our technology. So effectively, the majority of people are going to be looking at about 512K block sizes when they shift that data up. Okay? I've talked about the fact that we do that. Now, we obviously are leveraging S3 requests, puts, gets, and all that kind of stuff. So every single block that we send up, we've got to do a number of operations against it. When we're talking about public cloud, you guys all know that everything, literally everything that you do in public cloud costs money. Okay? So every little put, every get is going to cost a little bit of money in Azure S3. That means that the smaller block size you have, the more you're going to send up. The larger you are, the less. It's going to cost you more if you've got little, it's going to cost you less if you've got big. But then again, you guys know the actual operational costs of those puts and gets. They're like sub cents per operation. So they're never going to get out of control from that perspective. In terms of sizing for the moment, while we obviously release these in our monitoring products and third-party tools, because we based it on ReFS, like I talked about earlier, we can basically go to this calculator here and get an idea of how much data is going to be up living in the capacity tier.
Is that a Veeam produced calculator, or is that the
So that restore point similar is actually produced by Timothy Dewin, who's one of our engineers out of EMEA.
Okay.
So it's semi-official.
Got it. So at least the intelligence for that tool is coming from...
Exactly. That's right. Yep. All right. Okay. So in terms of what this looks like, you see here that we've got a lot of backup repositories. This hasn't changed too much over the years. The UI has got a little bit of a facelift. It's got some new features in it from update 4. But now you can see here we've got basically a number of different repositories, right, as I was talking about. We've got the ability to add Amazon S3. I've even got some S3 compatible. I've got Azure Blob. I've got a Swift stack, and I've got even connecting to Wasabi, right? Just to show you that, again, flexibility of choice is what we're talking about big time here. If I was to add a backup repository, now we've got basically the ability here to add direct attached network, DGIP, object storage. So through here, would go in, select the type that we want, enter in your details, and basically configure it up. Okay, very simple, very easy to do. Also, totally doable via PowerShell, and I'll show that in an example a bit later on. In the scale-up backup repository here, I've got a few here. This is my demo station, obviously. We'll check out Sober 02. When we go to the properties of this, now for those that know about scale-up backup repository, this hasn't changed too much. Effectively, we've got the performance tier, which is the local extents. So these are still as it was before. You're adding your local repositories to actually scale out on a top-level namespace with scale-up backup repository. Where it changes here now is the fact we've got the capacity tier option. And this is how you actually extend it to that cloud. So we're extending it with object storage. We're selecting the object storage repository that we created previously, and we're basically saying where we want to go. We can define a window of time. So again, in terms of saving on charges, if you want to only dedicate a certain window, if you've got metered connections, or if you only want to protect the obviously the pipe, you can basically permit or deny. And this is where the operational restore windows come into play. Okay, I talked about the fact that this is where you set it. So I've got it to 1 here because for my demos, I want to get data quickly into the object storage. But effectively here, it defaults to 30, and it's up to our users, our customers, to what they want to set it to. Okay, again, it's going to vary depending on their own requirements, but again, the freedom of choice there.
Do you give any kind of advice or in here to say most of 99% of your backups over the last year have been from the last 60 days, so we'd recommend that?
Yeah, similar question to what was asked over there. There's nothing that suggests that obviously automatically, but it's a really good request. So product strategy team, we're going to take that on board.
So
on here as well.
On that as well, do you do like reporting and monitoring of how long things are taking to move? If I've got into a situation where I've never caught up, and data is continuously moving, maybe there's a bottleneck that's not somebody.
Yeah, so that will be, and I'll show you that in the job. So the job will show you what data's moved, how long it's taken, and those bottlenecks. Typically, Veeam has those bottlenecks that shows network, source, target. We still have that as part of that job.
Okay.
Yeah. Interestingly here, the override is happening. So we've also got a way to basically manage the data on the Sober. Okay, so if you run out of storage, it's going to basically shift it at 90%. So a way for the Sobers to not fill up on space. It's quite important. Traditionally, for those that have managed scale-up backup repository, you know, obviously if you run out of space, it's not great. This is just a way to basically, I guess, overfill to that actual place there. In terms of the job, go down here. We've got a couple of jobs here. So you can see we've got these Sober offload jobs. And these are the jobs that run every 4 hours, if you have a look at the timings there. And if we click on one, I'll try and find one that's done some work. There you go. So you can see in this case, we've processed 3.2 gigs, we've read 3.4, we've only shifted up 498 megs, okay? So again, source side DGIP, very smart, very efficient in the way it's shifting its data. When you have a look here at the bottom, you'll get some information about what the bottleneck is as well, to your question. What's the busiest? Okay, in this case it was the source, so we're kind of okay. So you're going to get information about where it's actually going to bottleneck, if anything, and then adjust based on that afterwards. Okay, in terms of what it looks like, we've got the list of our jobs here. Okay, so if I click on this machine, you can see that every single item is still available to us. Again, the fact that we can see the VBK file, even though all of the data is basically sitting out in the object storage, we can still manipulate it. We can even do an instant VM recovery. This is really cool. I actually demoed this at Velocity, live on stage, working beautifully. So actually taking a VM. You can see here that we've got a lot of the points. This is local. This is on the performance tier. These points are sitting here out on the object storage. Okay? So I could basically click on here and go next, 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 and do an instant VM recovery, but the data is sitting within the object storage, and it's going to stream the data through, and we're going to mount that VM directly on ESXi and run that VM with data sitting in S3. That's pretty cool technology, right? You can't do that if you're just archiving. You have to have this tiering solution to be able to do that technology. A very big differentiator here. Okay. Over here as well, if I click on properties, And if I click on one, you'll see basically here, this is effectively giving you an overview of what this particular machine has by way of points within this backup job. And you can see here that we've got some slightly different icons to basically say where the data is, where the data isn't. So if I was to right click here, this is basically doing a rehydration task. We can pull the data down. Very important, again, to not be locked into a particular object storage. If you want to pull it out and put it somewhere else, you can basically rehydrate all the data locally and then choose a new object storage repository and have it go through the job again. Okay, very good from that perspective. The last thing I'll show here is the ability to run the tiering job now. Okay, so if we basically right click on that, it's hidden. We've put a control click in there to basically run that tiering job again. Okay, mainly to protect against overuse of this particular feature, okay, in terms, because you are potentially going to pump a lot of data out. Okay, the overheads locally aren't huge, but in terms of what it means for data moving out, that's why we've put in some guardrails into it. Okay, so now I'm going to show you a very quick demo as well about some of the resiliency in here. So quickly go to this machine. This machine is a fresh Veeam backup replication example. Actually created this machine with the automation and orchestration tools that Michael talked about earlier, which is on GitHub, which we've linked to. Effectively, what I've got is a situation where if you had a on-premises site that was using the capacity tier and you had a disaster there, okay, so say something blew up, there was a bomb, you lost your site. How are you going to get the data back? Now, anything that was local on the performance tier is gone. We understand that. You know, hopefully you've got some sort of backup sitting somewhere of that, right? It's obviously 3-2-1 rule of backup. Important to understand as well, and one thing I probably haven't touched, is that because we're tiering, there's only ever one copy of the data, okay, in this performance tier, or it's in the object storage repository. There's never two copies. It's either performance tier or it's shifted into the object storage. This is why it's not a one copy sort of 3-2-1 rule situation here, okay? You still have to bear in mind that you still want to have one copy of your data off-site, even if you're using capacity tier. So you can still look to a Cloud Connect provider to do Cloud Connect backup as an example. In this scenario, what we've got is we've had a disaster. I want to basically recover what I can off the object storage that's sitting in Amazon S3. So what we're basically going to do, you can see in the backup infrastructure here, I've got no repositories set up. I've got no jobs, got no VM data. What we're going to do basically is connect to the same object storage repository that we had set up on premises, using the same credentials, connect to the same bucket, connect to the same folder. Okay? So what I'm going to do, just for the sake of time, I'm going to run a PowerShell script, which I've configured, which is going to be available on GitHub after this on our Veeam hub. And what this is going to do, this is going to go and start to magically basically create the object storage repository. It'll create a repository, and then it's going to create a scale-out backup repository itself. So there's something popping up with the brilliance of automation. We're going to get the repository set up in a second, and then we're going to get the scale-out backup repository. But what it's going to do here, it's going to basically go to see if any backup files already exist on the object storage, okay, on that capacity tier. And when it does, it's going to basically say, do we want to resync that data? Okay, so in a couple of seconds, once it goes through, we're going to get the prompt to basically say, resync, here it is. So I'm going to go, yes. I'm going to ask him one more time. And now what we're doing is we're going to go and start to rebuild the indexes. So if I actually open Resource Manager, you'll start to see some connectivity through to Amazon S3, okay? And what you'll start to see is the reconstitution of the archive index and the actual metadata in the shells locally, pulling the data down. So this will take about 6 or so minutes to get through. It's important to kind of walk through the process. While it's happening, if we go here, you'll see that this is the actual repository on the performance tier. In a couple of seconds, we'll see an archive index folder built out, and then that'll start to download the archive index, which effectively then understands what blocks are sitting in object storage versus what is linked to the metadata. And there you can see we started that process, okay? So it's going to go on and do its thing for a couple of minutes. While it's happening, it's worthwhile showing you a little bit about what it actually looks like in S3 at the moment. There we go. Okay, so you can see here, I mean, this is obviously built up. We set the bucket, we set a folder name, and then we build out the structure. In that structure, we've got a bunch of parts, we've got a bunch of descriptors, we've got archive indexes, all the files that I've talked about previously. If we go into this part, you'll see here that we've got a number of different files here. Now these files add up, if we add them up quickly, 5, 10, 15, 20, it's about 22 megs worth, okay? This is the metadata, okay? This is what we're rebuilding locally on the other side. And again, as you saw in my first animation, we've shifted this metadata as part of that offload process in here, so we've got it backed up just in case. Again, resiliency is very important for us. So I'll go back here and hopefully we've started to build actual backup files. Let's have a look and see what we're up to.
What does the S3 bucket policy look like?
In terms of the IAM?
Yeah, the IAM for that bucket.
So basically we have got a way to scope it specifically in terms of access. What I've just got here is basically an access key and secret key from a top level root access in here, but you can make it as granular as you want from a security perspective. So I think on one of our KBs, we've got basically the IAM role template that you can put in to have it as granular as, well, I guess as specific as you want for access.
Can the GUI provision the S3 bucket for you with the proper roles and?
So it won't actually provision the bucket. The bucket has to be pre-configured.
Okay.
It will create the folder though, and basically then obviously do the folder. So the bucket folder. But as I've got scripting and PowerShell examples where I've done that whole process though.
Okay.
So I guess from a holistic point of view, it's out there in terms of how you do it end to end.
Right. I'm always concerned about people misconfiguring S3 buckets.
Yeah, of course. Yeah, exactly. There's guidance out there to basically make sure they don't do anything silly.
Right.
Yeah. That said, the data is not really reconstitutionable unless you've got Veeam backup replication and the actual username and password. You know what I mean? So if you got hold of that data, there's not too much you could do with it from the point of view of, it's still a danger, but yeah, obviously we want to make sure that people are doing the right thing.
Right.
Just quickly, so now you can see here, we're synchronizing now the actual files, the bib files, okay? So you can see here now we're rebuilding these files out. So if I look here and go back, now we're actually rebuilding the actual full backups, and look at the size of them, 22 megs. That's basically the metadata, okay? So just to prove that when we're rebuilding this, we're not bringing everything back, we're rebuilding those shells, the dehydrated VBKs, have the metadata, okay? But pointing to the actual real data that's sitting in the object storage, okay? So think of this in a scenario from a disaster's point of view, at least you've got this data back. Depending on the operational restore window, once this process is finished, and this finished in 5 minutes 34, which is not too bad, we can now go back. We'll have imported jobs, and you'll see here we've got the job files here. We've got this VM. We can now basically do an instant VM recovery of that VM directly off the object storage. Pretty cool technology, right? So that's this part done. Any other questions about the cloud tier, capacity tier, or anything that we're doing in this space? Because again, like I said, very innovative. It's a huge differentiator for us.
I'm curious how you position it as a major differentiator based off of the other offerings that are out there with cloud tiering. What do you think are the huge or big differentiators from other products that are doing cloud tiering? Yeah,
so you've got to actually check that they are doing cloud tiering, number one. Because a lot of vendors that I've looked into are actually doing archival as such, shifting big chunks of data across into object storage, having to pull them back before they do any operations. That's one of the biggest things, right? The fact that we are literally treating this more like a file system than an archival system. And then secondary to that, what you can then action against those files in a recovery perspective. Again, all the options that you saw, instant VM recovery, full file level recovery, that's the big differentiator. The fact that we lose nothing of that functionality. I can guarantee that if you look at other solutions, you will lose a level of functionality because the technology isn't the same as that.
Okay.
Yeah, that's the big differentiator there. And software agnostic as well, big part of it. Software driven, agnostic, all that kind of jazz.
So on the one hand, we have the ability to tier to the cloud in the scale-out backup repository model. On the other hand, if we want a Windows-based backup repository in AWS that has to be EBS backed with a large volume, we're potentially being billed for all of that storage up front and not on use. So there's kind of a middle use case that's not being addressed, I think.
Yeah, so think about that. So what you can do is you can actually have, if you want to put your repository in AWS or Azure or wherever it is, you can treat that EBS volume as a very small volume with less cost, and then actually use the capacity tier to send it off to object storage itself. So you're reducing cost of that particular EBS volume in that way.
The operational restore window, you saw in this demo, you had 1 day. Oh, sorry. Yeah, out of the box, you had operational restore window. It's 30 days. It's set to 30 days. You reduce that down so that the EBS is only 1 day or 2 days.
Yeah, in fact, that's so Michael and I have done much work around VMware Cloud and AWS and working out how to have the best sort of balance of that. And we basically push a repository into EC2. We do a very small EBS landing zone, and then we set the capacity tier to be aggressive and basically shift all the data to S3.
So with that, is there still a plan to add, to allow you to leverage a cloud repository directly, even in an archival model?
Directly to object storage.
Right.
So that's something we get asked about often. It's something that we are considering.
Okay.
Yeah.